Hello everyone. Alright, now it's our exercise 8 and we enter the trigonometric functions. So there is 3, the sine graph, the cos graph and the tan graph. Alright, so first thing, I gave you the 3 different typical graphs. So that's the sine graph. You see the origin is 0, 0. And that's how you differentiate it from the cos graph that has an origin on the amplitude point here, so usually 1 unless it's shifted with the q value. And the tan graph is this one with this repetitive shape there. Alright, so description of the parameter for the equation. So the a is the amplitude, so that's the difference from the rest to the crest. The b is the wave, or the number of wave in 360 degree. The P is the shift right left and the Q is the shift up down, so that didn't change. Alright, there is asymptotes only for the tan graph. You can see here there is some vertical lines that's not going to be reached by the graph. It goes to positive and negative infinity here. What you have to know about the trigonometrical graphs is that the x-axis is now in degrees because you're using the trigonometric circle to calculate the values. So you're not going to choose numbers from -2 to 2 anymore. That's going to be a lot too small. You're looking at degrees as degrees in a circle. So a full circle is 360 degrees. A right angle 1/4, it's 90 degrees. So that's what you have to use for your x's value now. So, like always, you keep your 0 as center, and you're going to take values on the left with negative x's. For instance, -90, -180, -360. And on the right hand side of your x, or of your 0 for x, you take positive values like 90, 180, 360. That's an example. You can add some 45 degree, 135 degree, 270. So example 1, we're going to try with a sine graph first. So here the graph is sine x plus 1. I wrote the brackets around the x just to force you to realize here the sine only apply on the x, the plus 1 is on the result of the sine. Alright, so here sine x plus 1. I do first the sine of the x value, then I add the 1. So if I take -360 degree, I can use my calculator. Sine -360 degree equals 0, plus 1, 1. For -180 degree, sine -180 equals 0, plus 1, 1. Sine -90 equals -1, plus 1, 0. Sine 0 equals 0 plus 1, 1, etc., etc. Then I need here quite a lot of points to draw my sine graph because it's a repetitive wave pattern. So if I only use a few points, I might feel like I've got always the same number repeating the whole time, which is just an illusion. So you need to have enough x's. If you always get 1, 1, 1, 1 for any x value that you're taking, it's because you don't have enough x's. So you need to skip and add more x's because you might be on one specific interval that will give you always the same result. So be careful. If you always find 0 everywhere or 1 everywhere, it's not that it's wrong, it's that you don't have enough x's. So you need to add more to see where is it going, up or down. Alright, so here, once I've got my table, like always, I'm going to plot the points. So here you're plotting 360, 1, etc., etc. Then, once you've got enough points, you draw your sine graph. And from there, you can see that you can find the amplitude. The amplitude is the difference from the resting position, so the center of your wave, to the crest. So for this example, A is 1. That's 1 unit from rest to crest. And in the equation, there was no number before the sign, so that's a 1. A is 1. B is the number of waves into 360 degrees. So here, from 0 to 360, 1 up, 1 down, back to resting position. That's 1 full wave. So that's 1 wave into 360 degrees, which means the letter B, the number B here is 1. Alright, and then, not to change anything, you have the P and the Q value. The P is on the X, so here there is nothing added or minus from the X, so there is no P value, no shift right left. And the Q is the last one, that's here the +1, so that means the whole sine graph is shifted 1 unit up, which is what you can see, the rest position, which would be normally on the x-axis for 0, is now shifted everything 1 unit up. So it respects the same thing than the other graphs, parabola, hyperbola, etc. Alright, so that's for the sine graph. Then you have an example 2 with a cos graph. So this one is a 2 cos x minus 1. No brackets here, so the cos is only on the x. Then you time by 2, priority on the multiplication. Then you add minus 1. So be careful with your calculation. First, for instance, if you take x equals 0, cos 0 equals 1, times 2, 2, minus 1, 1. Alright, so then once you've got enough x's and y values, you plot. And then you see your pattern. Cos wave, repetitive pattern, right. Then, can you see your resting position is now 1 unit down because you had a q equals to minus 1. Your amplitude from rest to crest is 2, which is your parameter A in front of your cos. And you have no shift right-left because the x has no p-value, so it's not shifted right or left. Wavelengths, number of waves, 1 from crest to crest, 360 degrees for 1 wave, so the B is 1. Alright. Last one, the tan. So I gave you the normal tan graph, the basic, for you to see it at least once before you start the homework. So tan x, same, you have to choose quite a lot of x's value to have the full tan graph. So for instance, tan 0 equals 0, tan 45 equals 1, tan 90. Your calculator is going to give you error. It's because it's an infinite value. So that's, remember, if it gives you error, it's the asymptote. So technically you can write or infinite or the 2 lines like we use for asymptote in the hyperbola. And then you plot. So you can draw the asymptotes here, and you can see that it's going to give that shape everywhere with 1 full wave equals to 180 degrees. So for the tan graphs, 2 half waves into 360 degrees. Alright, that's it. So be careful for the trigonometrical graphs. Use x's between 360 and minus 360, at least 90 interval for each. If you don't see the graph nicely, you can add 45-degree interval for x's to make it more neat and more precise. Alright, now homework. You take your book and you practice with 8.1, 8.2 and 8.3. I want to see the 3 graphs, and you tell me exactly I did in that example 1. what is the amplitude, what is the wave, and the P and Q parameter. So you describe your graphs when you sketched it. All right, that's it for the moment. Enjoy. Bye bye.